Welcome to our presentation on mastering date functions in EViews. This is an essential workflow for university students, graduate researchers, and econometricians. As the quote from Peter Drucker reminds us, time is a critical resource, and in econometrics, managing the time dimension of our data is paramount for sound analysis. Imagine you have daily stock price data, and you want to analyze its monthly behavior. Without proper date handling, this simple task can become a major source of errors. So, why is managing time in our data so challenging? And what are the risks if we get it wrong? Let's explore this on the next slide.
The core problem is that raw temporal data, as we often receive it, is rarely ready for analysis. It can come in various formats like 01/02/11 or Feb 1st, 23, which are ambiguous to software. This ambiguity is a significant risk. If EViews doesn't understand the date structure, it cannot correctly calculate lagged variables, such as y-1, or perform seasonal adjustments. This can lead to incorrect models and invalid forecasts. The solution lies within EViews' powerful date functions. These tools allow us to properly identify, convert, and extract time-based information, creating a solid foundation for our analysis. If EViews misinterprets 01/02/11 as February 1st instead of January 2nd due to regional settings, any analysis of monthly effects will be fundamentally flawed, potentially leading to spurious regression results. To tackle this challenge systematically, we need a clear strategy. Let's look at a strategic roadmap for handling dates in EViews. Our workflow strategy begins with identification. The first step is always to determine how EViews is interpreting your date column. Is it a string of text or a numerical value? If the data is not a proper date object, the next step is to convert it. We use functions like @dateVal to standardize the data into EViews' internal format, which is a serial number system. Once the data is in a structured format, we can manipulate it. This is where the real analysis begins, such as creating dummy variables for specific months or lags for dynamic models. The flowchart visually represents this. Starting from raw data, if it's not a date object, we convert it using functions like @dateVal. If it is a proper date object, we then decide our analytical goal, isolating seasonality using extraction functions like @month or @quarter, calculating duration with arithmetic functions like @dateAdd, or changing frequency with structure resize operations. All paths lead to a structured work file ready for analysis. This slide outlines the comprehensive EViews date toolkit, categorized into 4 main functions: identification, extraction, manipulation, and conversion. For identification, functions like @date and @now help us determine the current date information within the work file. Extraction functions such as @year, @quarter, @month, @day, and @weekday are vital for isolating specific parts of a date, which is critical for finding seasonal spikes, for instance, in fourth quarter retail sales. Manipulation functions, including @dateAdd and @dateDiff, enable date arithmetic, which is essential for financial calculations such as days held. Finally, conversion functions like @dateVal, string to number, and @datestring, number to string, act as a bridge, transforming human-readable text into machine-readable logic, and vice versa. This slide illustrates the critical concept of frequency conversion in time series analysis, emphasizing why careful consideration of the method is essential. When converting data from a high to a low frequency, such as daily data to monthly data, we are performing aggregation. The choice of aggregation method depends on the nature of the variable. For instance, for a flow variable like GDP, you would typically sum the daily values to get a monthly total. For rate variables, like interest rates, an average is usually appropriate. And for stock prices, you might take the last value of the period. Conversely, when converting from a low to a high frequency, such as annual data to quarterly data, we engage in interpolation. This process involves creating new data points where none existed before. EViews offers tools for this, such as linear interpolation, which assumes a straight line progression between known points, or more advanced methods like a quadratic match. The right-hand side of the slide summarizes these two concepts under frequency matters. Aggregation requires choosing a method like sum versus average based on the variable's inherent properties. Interpolation is about generating missing data, and EViews uses date functions to align these processes automatically, ensuring consistency in your time series. EViews stores every date as a serial number. This number represents the total count of days that have passed since a fixed starting point, which is January 1st of the year 0001. The implication of this system is powerful. It turns dates into simple integers, allowing for direct arithmetic. You can subtract one date from another to find the exact duration in days. A classic example is in finance, where calculating the holding period of a stock is as simple as subtracting the purchase date from the sale date. The formula is days held equals date sold minus date bought. For instance, January 3rd, 2005 is stored internally by EViews as the number 731948, meaning 731,948 days have passed since January 1st, 0001. First, EViews uses the proleptic Gregorian calendar. This is the standard calendar we use today, extended backward in time. This ensures consistency across historical data. Second, your work file must have frequency consistency. To use lag operators like -1, EViews needs a defined frequency, e.g. monthly, quarterly, to know what one period ago means. Third, be mindful of regional settings. Functions like @dateval interpret ambiguous dates like 01, 02, 03 based on your PC's settings, US versus EU. Importing DD/MM/YYY data on a machine set to MMDD/YYY will corrupt your timeline. Finally, ensure string precision. Ambiguous text dates can cause errors. It's always better to use an unambiguous format like YYYY-MM-DD when preparing your data for import. If you are a researcher in Europe with data in DD/MM/YYY format, and you send your data to a colleague in the US whose computer uses MMDD/YYY, the date 07/05/2023, May 7th, could be misinterpreted as July 5th, completely altering the results. Once we've managed these technical details, we can start using date functions for what they're really meant for, economic analysis. Let's see how. Date functions in EViews are not merely for data management. They are powerful tools that can act as regressors within your economic models. They allow us to precisely quantify various economic phenomena, such as seasonality and structural changes. For instance, to capture the January effect, where economic activity might be different in January, you can create a dummy variable using the command series jan-dummy equals @month equals 1. Similarly, a weekend effect can be modeled with series weekend effect equals @weekday greater than 5. And a structural break representing a crisis post-2008 could be series crisis dummy equals @year greater than 2008. The beauty of EViews is that these logical expressions, like @month equals 1, are automatically converted into 0-1 dummy variables, where 1 signifies the condition is met and 0 otherwise, making them ready for immediate inclusion in your regression analysis. This slide compares how Excel and EViews handle time series data, highlighting the strengths of EViews for econometric analysis. In Excel, dates start from 1900, and it uses a cell-based logic, which, while flexible, carries the risk of alignment errors, especially with drag-to-fill functions. EViews, on the other hand, starts its date system from year 0001 and employs series-based logic. Its inherent structure automatically enforces alignment, which is a significant strength. The key difference lies in how EViews handles the time dimension. It is built directly into the mathematical operations and automatically manages regressions, ensuring that when you reference a lagged variable like x-1, it genuinely refers to the previous period, minimizing human error and ensuring data integrity. This slide outlines the core menu hierarchy in EViews for handling date-related operations. Most of these functions are found in two primary areas: the quick generate menu, used for creating new variables, and the proc structure menu, which is essential for defining the file's time dimensions. First, to generate variables or use at functions for date manipulation, you'll navigate to Quick Generate Series. This is your primary tool for creating new date-based series. Second, to change the frequency or define the timeline of your work file, you'll go to Proc Structure/Resize Current Page. This step is crucial for ensuring EViews correctly understands your time series. Finally, to control how EViews displays your date results, you can adjust settings under View, Properties, Numeric Display.
This slide focuses on the Series Properties Graphical User Interface, or GUI, in EViews, illustrating a fundamental concept, the distinction between how data is displayed and its underlying value. On the left, we see the Properties dialog for a series. This menu allows you to customize various display settings for your data, such as the numeric display type, date format, column width, and justification. For instance, you can choose to display dates in mm/dd/YYYY format, or show only a 2-digit year. The crucial takeaway, highlighted below the windows, is that changing the display does not change the value. This means that while you can format dates in many ways for human readability, EViews internally processes them as serial numbers, which remain unchanged regardless of the display format. The panel on the right, titled Display versus Data, reinforces this point. The computer inherently processes dates as serial numbers, a continuous numerical representation. The various formatting options are merely for the human eye to interpret these numbers more easily. As a helpful tip, EViews allows you to instantly toggle between number and date views directly within the Properties menu. This makes it easy to switch back and forth to see both the human-readable date and its underlying numerical value without altering the data itself. This slide illustrates the frequency conversion dialog box, which automatically appears when you copy data between pages with different frequencies. The dialog offers methods for both high to low frequency and low to high frequency conversions. For high to low frequency conversions, such as daily to monthly data, the default method is average, with sum and last as other options. For low to high frequency conversions, like annual to quarterly data, the default is linear interpolation, with quadratic as an alternative. It is crucial to always check these settings, as the default average may not be appropriate for all variables. For instance, when converting GDP, a flow variable, from a high to a low frequency, you should use sum rather than average to ensure accuracy. We will now conduct a case study to test a famous financial market anomaly known as the January effect. The objective is to test the hypothesis that stock returns or trading volumes are significantly higher in January compared to other months. The first step is data preparation. We need to load our data into EViews and inspect it. It's crucial to verify the work file structure and ensure it has a defined frequency, such as monthly or quarterly, so our date functions work correctly. In this case, we are using a dataset of NYSE trading volume. The data range is from the first quarter of 1888 to the first quarter of 2004, giving us 465 quarterly observations to analyze. Step 2 is to generate our key independent variable. We do this using the Quick Generate Series command in EViews. The logic is simple and powerful. The command jan equals @month equals 1 tells EViews to create a new series called Jan. For each observation, it checks if the month is January. If the condition is true, it assigns a value of 1. If false, it assigns a value of 0. This is the fastest and most efficient way to create seasonal demi-variables in EViews, avoiding manual data entry and potential errors. This slide demonstrates a crucial preliminary step in data analysis, visual inspection. Before diving into complex calculations, we first ask, do returns spike when January equals 1? We look at the chart, observing if there's a visible correlation between the January periods, indicated by the shaded bars, and higher returns. An arrow highlights a clear spike during one of these January periods. Then, we perform a quick quantitative check by comparing the mean returns. The statistics clearly show that the mean return when January equals 1 is 5.2%, significantly higher than the 1.1% mean return for all other months. This preliminary check helps us confirm if there is a visible January mean that is substantially higher than the rest of the year, giving us initial evidence for further investigation.
This slide displays the estimation output for our regression model. The model is specified as returns t equals alpha plus beta times Jan t plus epsilon t. The primary focus of this output is on the coefficient beta. This coefficient quantifies the difference in the intercept for January compared to the base months, helping us understand the January effect. The final step in our analysis is to interpret the regression results. We found that the coefficient for the January dummy variable is 4.1, with a p-value less than 0.01, indicating high statistical significance. This means that, on average, stock returns are 4.1 percentage points higher in January compared to other months. This result is statistically significant, providing strong evidence in favor of the January effect. A diagnostic check reveals a Durbin-Watson statistic of 1.95, suggesting no serious serial correlation. In conclusion, the use of the at-month date function successfully isolated a specific time period for rigorous testing, validating our approach. For next steps, we could expand this analysis to test for effects in other months, or use the at-year function to investigate structural breaks in the data. This slide provides a concise summary of essential EViews date functions, acting as a quick reference or syntax cheat sheet for common tasks. We start with basic functions. @date retrieves the current observation serial number, which is EViews' internal numerical representation of dates. @dateAdd, date, n, string units, allows you to add a specified number of time units, such as days or months, to an existing date. This is crucial for creating lagged variables or forecasting.